All right. 5.4, modeling and optimization. That stuff works miracles.
It does.
Oh, I don't use that. That burns my nose.
I had some expired.
Flonase.
I had some that was expired in the cabinet. Use it anyway. It worked.
Nasal spray doesn't usually help
It's
me.
just salt water. It's not gonna hurt. You could
Yeah,
just use
I was
contact
like-
solution. It's basically the same thing.
So wait, so I can just spray contact solution away?
Well, it's saline.
Oh.
Oh, there was a girl at when we played Arcadia who her contact fell out and she put water on it and then put it back in her eye and I was like,
That's how you get eye parasites.
Oh no, it hit the floor too. So I was like, bleh.
Oh no, absolutely not. I might soak it and then wear it using it, but probably
but
not.
Hers was
That's
like
funny
she
though.
put it under water for like 2 seconds and then put it back in her eye.
Kalia smacked the contact right out of her eye.
I've never had that happen
Yeah.
before.
I've had it happen.
I've had it happen. It was in 8th
It was
grade.
during a fast.
It was also during basketball game for me. A girl I knew like punched it out of my eyeball.
And it was funny because they didn't even call like a foul on that. And Kalia didn't even know she did it. And
Probably they didn't call foul. They probably didn't even see it.
I know, yeah.
All right, our strategy for maximum problem, so that's what optimization is finding like the maximum amount or the minimum amount. So the first step is understand the problem.
That'd be good.
Isn't that like the first thing for any problem you face?
Pretty much. These are all things that you should pretty much
I
already
just
know.
tackle things without understanding them.
Minus one part of this problem you would not do normally, and I don't think I do in any of our maybe one of our examples I'll do it. Step 2, develop a mathematical model of the problem.
Maybe you do that. You just don't know that you do that. How do you spell that?
Step 3 is the one that we'll only do sometimes. Graph the function.
What do you mean you spelled model with a W?
So waddle, bro.
Modway? Model?
Waddle?
Waddle?
Yeah. we put a W
Waddle.
instead of-
How?
You were just thinking of penguins, guys.
Oh, is the graph the function the thing we don't normally do?
I feel like I just said that. Is there an echo in this
Yeah.
room?
Sorry, I was stuck on Nathan's waddle.
Nathan's distracted.
Identify the critical points. They haven't gone away. And endpoints. 5, solve the mathematical model.
that's the one we don't
And finally, interpret the solution.
No dip, Sherlock. Why would I not be? I said, what?
I was telling Nathan.
Oh, Nathan didn't understand I was being sarcastic?
I think y'all have had too much like cough medicine.
I'm on like everything I could possibly be on right now.
You're struggling today.
Well,
Are you dyslexic upside down? He made a flower.
Aw.
There was something the other day that I saw online that I meant to save to see if Christian can make it. But I can't remember what it was.
Was it origami airplane?
No, it was something else, but I don't remember what it was.
Well, that is a word on.
All right.
Your smooch's Valentine.
Solve the problem analytically, support your answer graphically. Huh?
So there's another step? Or is that the next step?
That's the
Is that
examples.
7? Oh.
That make you feel
Oh,
better?
That's the notes?
Yeah.
Oh. Okay.
It's not worth having a notes video for that, so we're just gonna lump it all together as one.
Wait, are you recording?
Yeah, probably.
Just
What, did you have to say something that isn't?
well, no,
He just wants to make sure I can post it so he can go back. Alright, I'm gonna write the word problem so that you have them to go back at, like, if you do it. But if you don't want to write the problem, they're in the book. Maximizing area. What is the largest possible area for a right triangle? Bless you. Whose hypotenuse is 5 centimeters long and what are its dimensions?
what?
Alright, so I've got a right triangle, so I'm going to draw a picture. Sort of, almost. Let me try again. There we go. Hypotenuse is 5 centimeters. I'm going to call this side X, this side Y. Now, just in general, what do we know about triangles' side lengths?
If A and wait, hold on. What was I about to say? If you add up two
Is there
sides,
a triangle that like one of those 5 and one of those? Where's that there?
the sides of a like, you know what I'm trying to say though? Like,
You haven't said much, so I'm not
It's
sure.
like
You've
metal.
said 2.
if you add up two sides and they're like less than like one side, then that triangle does not exist.
Correct. So I know that when I add up any of the two sides, it needs to be greater than the other side, or equal to. It can be equal to, but that doesn't happen very often. So, what would the area of this triangle be right now?
5x1.
Area equals 1/2 the base times the height. So I'm thinking
I
it's
just
1/2
multiply
x
everything
times y.
1/2 xy. Yep. Now, what else do we know about triangles, specifically right triangles?
There's a 90-degree angle.
Okay. Great.
Is that what you're looking for?
No,
Oh.
not at all. But it's fine. I was in the process of drawing it when he said it, so I was just like, okay.
There's like special ones.
Is it like a 30-69?
I don't think I'm looking
No
at
idea. I'm talking about side lengths.
Yeah.
How would I find another side length of a triangle?
Oh, you gotta use like the law of
Pythagorean theorem.
The law of Pythagorean theorem. Yeah, that's what I'm doing. That's the law
So
of
formula for Pythagorean theorem with respect to this would be what?
Oh.
Five.
Y
Thing is-
squared
Y squared
plus
equals
x
y squared plus x
5
squared.
squared. Okay, I
Y'all
just
were
said it
saying
backwards.
like
Okay.
everything
X
backwards.
squared plus y squared equals 5 squared.
Yeah, that's what I said.
So what I'm going to do is I'm going to choose one of those variables and solve for it. Okay? And I'm going to get it by itself in this one. Then I'm going to take it and plug it into this one.
Okay.
So I'm going to get y by itself because, I don't know, feel like y. So y is equal to the square root of 25 minus x squared. Are we good with that part so far?
Yes.
Awesome. So now I'm going to take this and I'm going to plug it in for y in area. So area equals 1/2 x times the square root of 25 minus x squared. Now, we might want to consider writing that as 25 minus x squared to the 1/2 just to make life easier because we're about to take the derivative. So I'm going to write it like that. So how would I take the derivative? Yep.
Actually, I mean, like, can we distribute so we don't have to do a product rule?
No, because it's raised to the 1/2. You're going to have to do a product rule and a chain rule. It's just the reality of the situation.
I hate reality.
Just, yep, you're spiritualist. Reality's not real.
Okay.
So let's start with.
Yes, we're starting with the derivative.
Yes, okay, we already got to that point.
Anyone know what the first step of the product rule is?
Half. Okay, so 1/2 and x together.
Okay, great. So we're going to do this piece and this piece. Okay, now what?
Okay, so the 1/2 x times the derivative of the second piece, which is
I'm just doing a bracket because it's going to be a lot. So
1/2 times 25 minus x squared. To the negative 1/2.
Halves.
Wait, 3.
Wait.
No, negative 1/2
1/2 minus 1 is negative 1/2.
times
50. Nope.
negative 2x.
Yeah.
Negative 2x.
50.
Okay,
You were multiple.
now what?
Okay, now we can plus,
Now we're
plus, which would be 1/2 times, yeah, second piece.
Fantastic. Now we're going to set it equal to 0 and solve for
It takes
x.
me so much brain thinking to do the product and chain rule.
I really just finished writing it now.
I'm going to simplify it a little bit before I do anything else, just to make life a little easier.
That's nice. That made it all nice.
Oh my gosh. Okay. So, 2.5 cancel.
How do you figure out two?
So, I'm going to have over here on this side negative x squared over 2 root 25 minus x squared.
Wait, what? How did you get that again?
I put the x and the x on top with the negative sign, and then I put the 2 and this part on the bottom. Plus, now I'm going to do this part, square root of 25 minus x squared over 2. And I'm going to set that equal to 0. Now, I am going to, well, I'm going to see if y'all know. Nathan just says no. I need to solve for x.
Mhm.
Alright, so can you like
Oh, you're
make them have the similar denominator?
I mean, if you want to.
right. Is that not the way you would go about it?
I mean, I wouldn't.
And
Would
that's
you-
not
would
the
you
way
like
to go.
factor?
How about
How would you factor that?
how about I take this piece and move it over here?
Yeah.
So I'm
Oh my
gonna-
gosh, yeah, treat it like a, oh my gosh.
That's what you were thinking of, right?
I have to
Nathan?
forget, like, they're not, like, they're still numbers, so just do what you would do. Algebraic equation. Oh, yeah, change this stuff. Just take it out.
So now you can like continue doing the algebra and like
Okay, continue doing algebra. Great. How would I continue doing algebra? Cross multiply. So I'm gonna do this side's easy. So remember, cross multiply, be the pretzel.
I haven't used
So 2. Now look, these are the same things. So when they get multiplied, what happens?
they go away.
Square root goes away. So that's gonna be 25 minus x squared equals 2x squared. Now what? You can, but there's I would divide by 2 because that'll get rid of it. But yeah, you can. So that would be 25 minus x squared equals x squared.
Add the x squared.
Add the x squared. I'm going to put the x squared on this side though, just because
Okay.
I feel like it. I want the x on the left.
Now divide by 2.
So x squared equals 25 over 2.
And you gotta
And you gotta-
radical that.
Radical that.
Radical, man.
So
Sorry.
so what is that?
Equals
5 over square root of 2.
Okay. Why didn't you do plus or minus?
Because
I don't
It's-
know.
Should we?
Make me happy. Why didn't we do plus or minus?
the radical 2 is still in the. It's not plus or minus because
Because it can't be minus.
Why?
It's like
It's a-
dimension.
It's a dimension. It can't be minus. Thank you.
I forgot what that. We're bad. We're down here. I forgot what the problem was.
I know. That's why I was like, let me scroll back up. The fact that this is all one problem and we're not done.
What are we gonna do?
All right, that's our x dimension. Okay.
Wait.
That's a lot just for.
Okay.
Wait, that's just for that.
No, we already found y, right?
We did?
We have to plug x back into y.
Bingo. Okay. So I found x. So x is this. I'm gonna go back up here and put x up top, just so that it's up here. And then I'm going to find y, and then ultimately I'm finding area as well. So I'm just going to put all that up there that I'm trying to find.
The only person you can blame for having arthritis late in your life is yourself. Make confused.
What did he do?
Okay? Stop popping your ankle.
It's a myth. It doesn't cause
Yeah,
arthritis.
no, because it's just
All right.
pockets of error in your like feelings.
Y equals the square root of... So I solved for y, but I hadn't found y. So minus 5 over the square root of 2 squared, which is 25 minus 25 over 2, also known as 50 over 2 minus 25 over 2. Oh, and this is all in a radical. I'm writing it. Which is the square root of 25 over square root of 2, also known as 5 over the square root of 2. Now, I typically rationalize the denominators, but the book doesn't, so I don't care what you do. We normally say no radicals left on the bottom, but the book apparently doesn't care. I know.
We're being rebellious.
Now, I still have to find area, because I want to know what is the largest possible area.
Oh yeah.
Nobody needs area. That's fine.
Oh, wait, why is it-
So how might we find area?
You plug
X
those
times
your
Y.
values back into the formula.
Yes, plug it in. Area equals 1/2 times 5 over the square root of 2 times 5 over the square root of 2, which is going to give me a lovely 25 over 4. And they don't give units, so don't worry about it.
Wait, did we have the 25 over 4?
Square root of 2 times square root of 2 is 2.
Oh.
Times 2 is 4.
Oh my gosh. Yeah.
Real.
I don't know. That's
I had
it
the
was
same
4.
thought. I had the same thought.
Don't you love that all of this was one problem?
Oh, yeah.
We can just.
And that was
do that again.
in the easy section of
Are you
problems.
being so for real right now?
That was problem 2. They don't usually get easier.
Ah.
20 minutes. Maybe not really that long on that
Yeah,
one problem,
we're
but
gonna, like, talk for a second.
I think
the next one actually is a little easier.
It's word problems though, so like they could theoretically put the hardest one like, because it's mean already, because it's word problems.
Can I just make the thing you said that you had, or
Huh?
can I just like make the thing you said you had instead of doing math?
yeah,
Make the thing you
the
said.
Oregon
Oh, the.
Oh, I don't know what it was. I don't think I saved it. I should have, though.
Now with
You make an Oregon cat.
I think it might have actually been an alligator. Not gonna lie.
Yo.
Josh is-
That's cool.
Josh is-
All right. Another finding area. Show that among all rectangles with an 8-meter perimeter, the one with the largest area is a square. So what formulas do we know in regard to area and perimeter of a rectangle?
Area equals length times width.
I'm going to write that one there and the other one over here for a reason, so just FYI. What is perimeter?
2P, 2L.
Yeah.
Huh?
2E?
2P, I mean, 2L, 2W.
Okay.
Plus. Yeah.
Oh.
I was like, P.
2L plus 2W. So I'm going to factor out a 2 from both of these, so P is equal to 2 times L plus W. Now they tell us that it has an 8-meter perimeter, so that's a set number, so I'm going to replace perimeter with 8. Divide by 2, so 4 is equal to L plus W. Now I want to get one of the variables by itself, so I'm going to get W by itself, so subtract L, so W is equal to 4 minus L. Now I'm going to use that in the area formula and replace W with 4 minus L. So area equals L times 4 minus L, also known as 4L minus L squared. Now what? Derivative. So DADL would be what?
Would be 4 minus 2L.
4 minus 2L. Now what?
Equal to 0.
Yeah, so it's 0.
Add 2L. Wait, no,
No.
what would we do that?
Subtract
Subtract 4.
Subtract 4. Yeah, don't listen to me.
And then
Then
divide by
divide
negative 2.
Yeah, the negative 2.
And then you get positive.
Yeah.
It's okay.
My brain doesn't go as fast as.
All right, so now it says to show that, okay? So I want to show that with a sign chart now. Okay? So to determine max and min. So if this is 2, I'm plugging it into the derivative. So if I plug in 0, what do I get to this one?
4.
Positive. What about 3?
Negative.
Positive.
Negative.
So if it goes from positive to negative, it's a
Max.
Max.
max. So we've shown there that has basically proven the point that it's a max. Okay.
Oh, that is the. Oh, okay. Oh, largest max.
Because it said show that, that's why we did it, but we didn't need to do it in the other one.
Okay.
Okay.
So now it says, let's see. Basically it says show that it's a square, so we would do just now, we have the length, I need the width as well. So the width, we take the number and plug it in. So 4 minus 2, so the width is also 2. And they did give us units on this one, so we're going to put units on this. And so then ultimately the area of that would be length times width, which is 2 times 2, so 4 meters squared. Now they didn't specify dimensions, but do they want dimensions? They did a lot of work for that problem. All right. So they don't actually give dimensions. I mean, they explain that the dimensions are 2 by 2, but it was looking for the area of it. So, anyways. Okay. Six. This is the largest rectangle problem. A rectangle has its base on the x-axis and its upper 2 vertices on the parabola y equals 12 minus x squared. What is the largest area the rectangle can have? And what are the dimensions? So I'm trying to find the largest area and the dimensions, okay, for this problem. So to give us a visual, okay, this is a parabola. It is shifted up 12 and it is reflected, so it's flipped upside down. Okay, remember how to look at that for a parabola. Okay. So I'm gonna, oh no, not that. Heavens no. Alright, so up here at 12, when x is 0, wait, no. Let me find the one. It's trying to find it when y is 0. Okay, well anyways, it's gonna be somewhere over here. Doesn't really matter exactly, but okay, so something like that. That's my parabola. The rectangle has its base on the x-axis and its upper two vertices are on the parabola. So basically, here and here. Oh, not that. Okay, so I've got the base of my rectangles on the x-axis, and then the upper two vertices are on the parabola. So I know that the area of my rectangle is going to end up being length times width. This point here would be x. We don't know what x is going to be. And when it's x, it's going to be 12 minus x squared is the y value. So if I call the distance from here to here x, then this also would be x because it's symmetrical, right? Parabolas are symmetric. So this whole part here would be 2x. So this is x, or that's my length. Okay, my length is 2x. Okay, because there to there is 2x. Here to here, okay, this side length here is this y value. So 12 minus x squared. So width is going to be 12 minus x squared. Keep looking at the x's and the little squiggly that I drew and seeing a smiley face.
It does kind of look like it's weird.
It's a smiley face wearing a hat.
Oh,
So
he's wearing a hat. Like a dead snowman.
now I'm going to use this stuff and plug it in for area. Okay, so this is one we really couldn't have done without showing a graph. Okay, so this is where that, what is it, step 3,
Yeah.
that I was like, we don't really use it that often.
I don't think I would have understood the problem without drawing a graph on it.
Yeah, well, and that's the thing. You kind of have to have it for it to make sense. So I'm going to replace 2x and then 12 minus x squared. Now what might I do?
Distribute.
Distribute. So I'm going to get 24x minus 2x cubed. Now what?
Factor that or set it equal to 0.
What'd you say to do?
I said factor or set it equal to 0.
Factor would just undo what I just did.
Right. So I would probably set it equal to 0.
Can I set it equal to 0 yet?
Derivative.
Derivative first, then 0.
Come on, guys. What is this chapter about? Applying derivative.
dA dx. This is applying what we did from 5.1 to 5.3 with word
And
problem.
what we did in like chapter. I mean, sure, I guess.
Can I come in here because I can hear a lot of You wanna learn about?
Well, neither do we.
All right, what's the derivative of this?
24 minus 6x.
Sweetie.
Now what do I do, Nathan?
So equal to
Set it equal to
So
0.
don't say that.
All right, so now what?
Minus 24. Okay.
Divided by 6.
Divided by -6.
Okay, but like it's the same thing. Well, not
It's
it,
actually not.
you know what I mean.
square
though.
root.
Which X
Ooh,
is
wait,
2.
it's a yes.
Something better both.
Ugh, I love when it's a perfect square.
That's my type.
Okay.
So now what?
Wait, now we
Plug
know what
it
X is. So
into
The area.
area.
Yeah.
Plug in
So I'm plugging it into
the
this. So area is equal to 2 times 2 times 12 minus 2 squared. What's that?
Would be 32.
32.
Meters squared.
It's in meters.
I don't know. There's no name.
They didn't give us units.
you just
So
assuming
units
it's meters.
So you can say unit squared or you can just say area equals 32. It doesn't matter.
No, but like.
If it specifies units, you need them. If it doesn't, then it's fine.
Wait, even when I'm doing calculus, I'm like, wait. And I'm like, wait, is it insignificant figures? But then I'm like, wait, I don't need that. It's calculus.
All right, but what else did it ask me for?
Dimensions.
Dimensions.
Oh man.
Dimensions. So length is 2 times 2. Width is 12 minus 2 squared. So length is what?
Length is 4
Oh, okay, this
and
is easy.
width is 8.
So in the way the book will write it, they'll be like, it's a 4 by 8. Like that. But just specifying what it is fine too.
Wow, I got a whopping 2 problems on 1 page.
I got a whopping 2 problems on 2 pages.
Oh.
Alright, we're not going to solve it today, but I'm going to go ahead and write the problems. That way it'll be ready for us to start tomorrow because we have just a couple minutes left. Number 10.
How
The
much-
sh-
so much space would we need for this?
I would.
Probably.
Mine's a half a
Well, if
page.
you said you got 1 problem on 1 page, I would probably go to the next
Let's
page.
probably get the next page.
You have plenty of paper to finish like the rest of the year with, so come on.
At least 8 lines. Alright.
Don't stress, just write.
A 216 meter squared rectangular pea patch.
Rectangular patch.
Pea patch.
It's a pea patch.
Oh.
Like
Like
green like
patches of peas.
like green peas.
Oh, I thought it was like an actual
You
patch.
also forgot the G in rectangular.
Everything's like extra funny today for some reason. I don't know.
Guys,
I haven't had enough
Yeah,
caffeine.
real.
Is to be enclosed by a fence.
Why are you making?
We're just writing.
And
I
divided
was gonna sneak.
into 2 equal parts. By another fence. Parallel to one of the sides. Which also means it would have to be parallel to 2 sides, but you know, whatever. It's fine.
Yeah.
What dimensions for the outer rectangle will require the smallest total length of fence? how much fence will be needed? So we're going to be finding the amount of fence needed and then the dimensions. Okay, so just to give you a, I keep doing that. Just to give you a visual, okay, we have a rectangular patch, okay. When it's talking about a fence like down the middle, okay, or that's parallel, it doesn't have to necessarily be down the middle, but parallel, that means that it's either gonna
Oh no.
look like this, or it's gonna look like this. But I want to use the smallest amount of fence, so which one do you think it's gonna be? The one on the left, okay? The one on the right just looks like it's gonna take way more, right? So, we'll start with that problem tomorrow, looking at the perimeter and the area and figuring out how to optimize that.
I'm getting NyQuil right now.
What?
Isn't that making you go to sleep?
I think you